Hey guys, welcome. This is Infrastructure Track. Shawn Moyer and Nathan Keltner are going to talk about Wardriving the smart grid.
Hey. So actually, we were working on that initially, and we got a little behind, and so we actually just created a hot chick profile. We friended a bunch of people. That was kind of what we ended up doing instead. So, anyways, so, we should probably close that. Yeah. Go.
All right. So I'm Nathan Keltner. I'm on the security assessments team with Shawn for FishNet Security. We do penetration testing, vulnerability assessment, stuff like that for our day job. We had the opportunity to look at a lot of interesting smart grid infrastructure for part of a long-term engagement earlier this year. And it got us all talking about this and thinking about this, and kind of resulted in this talk.
Yeah, and Nathan's both of our qualifications for this were, and I always tend to do this to a fault, but basically one of our sales guys told us that he had sold a really big wireless assessment, and we started talking to him. We said, well, what are we assessing? And he goes, well, it's about 3,000.
IPs.
Devices, like 3,000 IPs. Oh, okay, yeah, that's cool. We've done bigger, network pens than that. No big deal. But yeah, I think they're all over Wi-Fi. Okay, yeah, no, we can. That's a really big wireless network. Like, a lot of collisions and stuff with that much traffic in there. And so we get to the kickoff with the client and start talking about it, and the client goes and shows us a bank of meters and says, no, it's this stuff over here. Isn't that Wi-Fi? Is that Wi-Fi? Right? That's what we thought it was. And so we spent a lot of time kind of figuring that out. And Nathan obtained a yellow belt in GNU Radio. So and I'm Shawn Moyer, principal consultant with FishNet's assessment team. Pen tester by trade. I actually worked at a VCR repair shop as my part-time job in college, and I'm kind of okay with the solder gun. I'm also remarkably resistant to sustained 110 volt burst. We've confirmed that beyond a shadow of a doubt in trying to do things like sniff live meters and open the cases and mess with them and stuff like that. So yeah, the general kind of overall topic that we're really on about here is smart grid and utility radio, and also kind of dumb grid radio as well. So a lot of the things that we're talking about are also in use in places where it's not necessarily smart grid per se.
So talking all of the wireless stuff that hooks all these different pieces together. All of the new advanced things that are coming out, the easiest way in general to lay that out with little infrastructure requirements all take place in the air around us.
Yeah, and actually not just I've talked to people in other utilities, gas and water and things like that, where they're still looking at a lot of these same kind of technologies, to collect data and manage information for all of their distribution points too. So all of this stuff is still kind of applicable there as well. They've been a lot slower to adopt, so obviously the electrical utilities are where a lot of this is going on, pretty quickly right now. And a lot of that is driven, as some people probably know, by the stimulus funds that have been issued to a number of utilities. The stimulus money actually from part of the funds for the overall stimulus plan were set aside for quote unquote green energy and smart grid. And those are all earmarked that they have essentially a shelf life of 2 years. And so you have utilities that maybe had 1,500 pilot smart grid meters sitting around that now all of a sudden are going, oh crap, let's wire the entire state, right? And let's hurry up and do it before we run out of funds. And so yeah, some open standards.
Yeah, some open standards. There's some of this that is available in like ANSI documentation or otherwise just kind of openly documented, and we have access to it. And then there's a fair amount of stuff that happens under the hood. It'll often be referred to by them literally as like their secret sauce, and it's the kind of thing that that you just don't know about until you start digging into.
I'm sorry, that's patented trade secret information, and we can't actually go into details about the. That's the standard answer if you call up a vendor and ask them about some of this stuff. So yeah, to Nathan's point earlier, it's with the rapid adoption, the fastest route to go tends to be to start throwing things together wireless. Actually, kind of an interesting analogy there is Africa in terms of cellular service. So in the United States, all of our cellular infrastructure is still, a lot of that is like wired under the hood. So we have all of this wired infrastructure. Africa actually leapfrogged a lot of that because they were a late adopter. And so they moved to setting all this stuff up via wireless right away. And that's kind of what the utilities are doing. So they may have some of these things that are some control pieces or some monitoring component that's on some kind of wired network now. But when you want to turn up a very large infrastructure very quickly before you run out of money, then wireless is probably the fastest path to go.
Right. So like Shawn said, rapid adoption, and as I mentioned earlier, minimal level of infrastructure that's required to get things up and moving.
Yeah.
So there's not necessarily anything wrong with that approach. As we looked at a lot of this, there's a lot of sort of noise in this industry right now, specifically in this particular topic, and there's nothing inherently bad about these particular types of approaches. The wireless tech that we saw overall runs the entire gamut from awful to great, and there's nothing inherently bad about it. But just given the level of complexity, the newness of the vendors, the newness of the tech, there's certainly a lot of room for fail.
Yeah, and for what it's worth, a lot of these things, we're seeing actually a lot of vendors in this space that specialize in co-sourcing this stuff. So vendors will actually come in and sort of run the whole rollout and run the deployment and run the infrastructure for the utilities and then hand it over to them after the fact to manage. And that's there's an entire market in the utility space that's just blowing up right now with coming in and running these smart grid rollouts for the utilities that are pushing this stuff really fast. And the utilities don't necessarily know the questions to ask. This isn't necessarily their wheelhouse. And so you're going from maybe some limited pilot rollout to citywide, statewide infrastructure all over wireless, and they don't necessarily know the right questions to ask. In particular, to James Arlen's points in his talk earlier, we have the folks that understand the SCADA end and understand the backside and how those pieces work and have been in that industry for lots and lots of years and get how all those pieces work. And then we have things like wireless where the kinds of questions that you should be asking there really are not that different from what you would be asking about how somebody set up 802.11n and WPA2 and how do you handle certs and authentication for a network like that.
With the big giant difference being that in those cases they're gigantic open standards that this industry's beat to death over a long period of time, as opposed to something that was rapidly developed maybe in somebody's spare time or in their basement in a startup and has not had anywhere near that same level of scrutiny.
Right, and in fairness, that's not necessarily always the case.
Right.
But yeah, you actually, if you go out and you read vendor websites for this stuff, not just AMI and meters, but smart grid technology in general, they will actually use things like proprietary encryption as a selling point, and describe that as this is a great asset that we have this proprietary protocol and this proprietary encryption that nobody has successfully broke it before. So who's looked at it? Well, nobody.
Yeah. The other thing you'll commonly see is all of the key buzzwords that everybody's come to expect. So somebody will throw out the word AES, right? And then the people on the other end of it that don't really know a whole lot about the details of how any of that stuff works, because they've never had to do it as part of their job, they'll see that and go, oh, great, okay, so it's got solid crypto. And it's like, well, no, not necessarily at all, because AES is one small component of an overall architecture that all has to work together and fit. And if it doesn't, then it's really no different than proprietary ROT 13 or something.
Right, and yeah, Tom Patrick has made the point a number of times that most of the time when you're looking at crypto or key management and things like that, it's not really about even finding a flaw in the crypto itself. It's in the implementation and the way it's been handled and the way it's set up. And a lot of those pieces the people that are making these product selections they don't know those questions to ask. Yeah, and so just to nail, and those of you that kind of get this stuff already can just kind of fall asleep for a minute, just to kind of nail this down. Some of the things that we're talking about here, AMI, you'll hear that term a lot, advanced metering infrastructure. You also have AMR, which is just remote read capabilities and things like that. And that's kind of an early adopter approach. And most of you probably have this. I know that I do. If you walk out, if you've had your meter swapped out and you have an LED instead of big dials turning right on it, if you look at it, you'll usually see something about cellular. If you pull information off the meter or look up the model and things like that, it's probably working over cellular network. And that's what a lot of stuff now is doing as kind of the toe in the water. And when you talk to the utilities that are doing that, they're like, yeah, we're not really so sure about how this other stuff's going to work out. So we're just going to get, basically they gain remote disconnect and remote read. They're not walking up to meters and reading data off of them and having guys in trucks doing that anymore. So that's kind of the first wave. For the radio infrastructure.
So radio tech, you do have everything across the board. You've got so proprietary RF, which, to be honest, a lot of them made themselves because there wasn't at the time a good product out there, or a good protocol out there that would do what they needed. I mean, you think about the type of environment that meters and other types of infrastructure like this needs to operate in. You've got very low throughput requirements, right? I mean, it's not like you're doing wireless broadband to your house or something. I mean, it's very small blips of information, probably spaced out across maybe 15 minutes, an hour, or longer, or just infrequent commands that come in and then acknowledgments that come back. And really, you just need to make sure that it gets there, right? You need to have some amount of fault tolerance built in so that you can go through like brick walls and it can bounce around all these different buildings and be able to get you that. And there were not a lot of great options for that, so some of them made it themselves.
Yeah, and some of these technologies, like once we got under the hood and looked at the ICs and the designs and actually pulled, and we'll get to some of that later, but like pulled things like patent docs and stuff, these are companies that the particular wireless tech, they created 15, 20 years ago. So you couldn't, you wouldn't be talking about, even things like UVDO or Zigbee or other stuff as options for it. So, that was, sort of designed with that mindset. In some cases, and actually, irrelevant to our talk, like doesn't apply, right? But in some cases, you're actually seeing power line stuff. So to some extent, think like X10. That's not probably an entirely fair assessment, but utilities are using the actual power line itself as a transport rather than radios. And there's a lot of rationale to that too. So if you can use your own wired infrastructure that you already have and piggyback along that for your network and your infrastructure, it makes a lot of sense. Something that you see, across the board in a lot of places, even at a simple level, is a lot of these substations and reclosers and sort of core infrastructure are already on maybe some kind of nailed T1 or a WAN or a 56K line or a modem. So that's a lot of the backside stuff.
And a lot of the stuff that people, particularly, or the people that we talk to in utilities, are very excited to get rid of for various reasons. It's rather expensive to run T1 lines out to individual devices. So.
Right, and that becomes cost benefit to going with some kind of wireless tech to do this.
So WiMAX, another common citywide thing that we've seen. WiMAX has the advantage of it being again open standard that has had some amount of people looking at it. You'll still run into, of course, configuration types configuration types of problems, possibly implementation problems, so that maybe if the tech itself or on paper looks great, we've seen some problems in some of the individual devices and how they're made and how they're hardened themselves. Oftentimes those little devices are little Linux boxes that have all the things you would expect to go with that. It's got the and I should clarify that when we say WiMAX here, this is in our experience not been WiMAX like the way you guys have heard of WiMAX being sort of an ISP or something along those lines where they're blanketing a city with a network so that you can do that type of data transfer. But these are private WiMAX networks that would be citywide. right? So it'd be owned by a utility or some sort of utility provider, and would be backhaul for all those individual devices within there.
Yeah, and for what it's worth, if implemented properly, you have a lot of the same. I always say like the nutshell definition of a lot of the WiMAX tech is that it inherits a lot of stuff from from 802.11. So it has pre-shared certs and the ability to authenticate clients on a per client basis and do per node encryption and all these other kind of things. So like if you set it up right and you lock it down, it's not terrible. You still have, and obviously people have proven that out with Clear and some of the other networks, you still have ways to join the network potentially if you have a device. And you do have, which is unfortunately sometimes the argument that we hear for the proprietary stuff, you do have consumer devices that you can buy that may make it possible for you to at least capture traffic in the network. The Zigbee stuff, and we have some more stuff on Zigbee in general. There's a gentleman with dreadlocks around here somewhere that knows probably way more than we'll ever know about that topic. So we're not gonna beat that to death. But that is something that you're seeing a lot of the infrastructure. Actually, not just for, I think what most people know about Zigbee is for home area networks and for your consumer devices in the home, thermostats and refrigerators and all this other kind of stuff. But there are also AMI vendors that are using Zigbee backhaul type stuff for neighborhood area networks and things as well.
Of course, cellular networks, as we already mentioned, oftentimes you'll see cellular networks for backhaul that'll plug into some other type of blanket RF or other type of network that it just uses that simply as internet backhaul in some cases, that it literally just straight over the internet in some sort of a encapsulated encrypted tunnel. But when you start looking at these individual devices and all the different types of options that you can get with them and the things that plug in, they'll always come with some sort of EVDO or CDMA or GPRS.
Yeah, and that has the same, a lot of the same disadvantages to a nailed circuit, which is that one of the reasons why actually WiMAX is getting a lot of adoption is that the utilities can get devices and get permission to broadcast on some range of spectrum, and not essentially they become their own telco or their own ISP and run that infrastructure. Whereas in the case of something like using Sprint's network or Verizon's or whatever, the cost is less than WANs and T1s, but they're still paying for bandwidth and service. So yeah, we have seen some Wi-Fi in this space too, which we kind of laugh at. But yeah, straight up, right on, straight up bona fide Wi-Fi, and with limited configuration capabilities and things like PSKs and no certs and all kinds of other nifty stuff. There's a vendor that's their big selling point in the AMI world that we use Wi-Fi. It's an open standard. Anybody can use that. And yeah, we're kind of on the fence there too. I mean, the issues, like say same things that that we sort of mentioned about WiMAX, which also apply to Zigbee. That it's an open spec, it's an open protocol. You can get the gear. Obviously we all have it in the case of Wi-Fi. But there's also a lot of merit to that as far as you as a utility can also see what the hell your network's doing pretty easily. So. Maybe neither good nor bad, I guess. Yeah, and we've kind of hit on some of that. A HON is a home area network. You have neighborhood area networks, and then also backhauls, some kind of out-of-band management or in-band management that is typically some kind of control channel for all of these devices, whether it be meters or whether it be substations or anything else. Yeah, and
when you get down to it, really at the end of the day, it's all old school SCADA that's somehow been bolted into some sort of a newer tech. In general, all the protocols that are in use are all been defined. Some of the the ANSI standard stuff, some of the things that we messed with, but all been around for a long time and have just been converted and bolted into the stuff we're talking about.
Right, and yeah, fundamentally that's how a lot of these devices work under the hood. It's all very well understood. So ultimately, yeah, somewhere in that in that transit, somewhere down the line, you're talking some SCADA protocol under the hood eventually. A couple of the AMI vendors have built their own, essentially transports that allow them to talk, in particular C1219 and 1221 SCADA are SCADA specs for talking to meters and stuff. So part of their secret sauce is that they have their own IP protocol that ultimately is just talking, SCADA to a meter on the backside. Yeah, and yeah, just sort of where adoption's at right now, and it's growing a lot. But obviously, California has Pacific Gas and Electric, who's not a customer of ours, so I can name them, has done a lot in this space. There's a lot of that going on. There's basically the way the stimulus money laid out, they identified utilities in sort of each quadrant of the U.S. and different utilities try to kind of disperse that money, equally. So there's little pockets where this stuff's moving really fast, and there's other pockets where it's slow adoption. And actually on here you can see actually AMR versus AMI somewhat on here. So yeah, you'll see a lot more of that. Yeah.
So ultimately, what we're doing is that we've given some means to join that network to every one of these devices, right? So when you're talking about, say, meters, right, then you've given that device and stuck it on somebody's house. Now, there's lots of ways that you can try to put controls around that, but at the end of the day, you've given them the tech that needs to do it, right? So I can, if you're not worried about, say, the law, right, and you just go down to an abandoned building and snap off the meter off the side of it and take it home and reverse it, well, what are you going to do about that, right? So signing, PKI, all of those types of things and types of controls that are good things that we talk about and we pat ourselves on the back for, with any sort of determined attacker and physical access, you're going to get it.
Yeah, and the larger point we usually make around that is that's why monitoring capabilities are so important. And we mentioned C1219 and these SCADA protocols they're massive, like gigantic. Like you can pay NIST or whatever, $200 for this, this whole reference set of all the commands and things. So there's all kinds of monitoring and logging capabilities that would, detect tampering. We found that in many cases, like none of that stuff was on by default in vendor firmware. So all of these test cases, and I know Jonathan Pollitt did a talk on meter tampering. I was unfortunately working on slides, so I did not see that, but and I've talked with him about it, over email and things. I mean, there's a lot of very obvious things that you can do to meters that will allow you to, to tamper with the device and impair their ability to disconnect your service, modify the data that the utility is seeing back, and all of that, and essentially interact with the network. Yeah, see also, Mike Davis's stuff from last year and Travis Goodspeed's numerous things on Zigbee and physical access devices and doing key extraction and voltage glitching and all that. So, there's essentially at the end of the day, you have access to that device. Yeah.
Kind of one of the other overall points that kind of always gets made. If you parallel some of these things that they're trying to do with, say, the DRM industry, and think about like satellite, think about content protection, like current stuff with Blu-ray or any of those types of things, or say like Microsoft on the Xbox or Sony, PlayStation, that kind of thing. These guys have been doing that for what? 20 years yet? Something, a long time, yeah. Right? And this is what they do all the time around the clock, and they can't get it, right? That eventually those protections will fall. That's a really high bar, right? And so to expect or to assume that someone that's designing this that maybe hasn't had that level of experience in protecting something that you've then given to someone and expected them to not be able to break it apart and open that back up, it's a very difficult thing to accomplish.
Yeah, and we typically haven't seen even some of the hardware protections that you see on other like consumer devices as far as like fuses and fuses for JTAGs and any other kind of hardware controls around a lot of this stuff. Like that, it just hasn't really occurred to people. And the thing that we like consistently will get is, well, that's really hard. That'll take like somebody a really long time to do it. And to make the satellite hacking sort of analogy to that, if any of you have does anybody have a Dreambox, or I don't even know if those work anymore. Like I just said screw it and got cable, but the deal with that stuff is that you don't necessarily have to be able to break, the particular codes for, for a satellite card yourself. You just have to wait for one person to do it and then share that information everywhere. So, same applies to the meter stuff. You've got these devices that are out there for 15 years, expected lifetime, that are very difficult to push updates to. And, when you identify something like that one time and, post that out on some equivalent of, DVS forum or whatever and share that information, then everybody's going to have access to it. Yeah. And yeah, we've hit on some of that. We run into a lot of stuff where, we'll hear basically the proprietary element of their technology or the secret stuff they do as being, something that is a selling point for the security of their devices. There's a lot of stuff like that we see, in both in marketing stuff and also just like in the devices themselves. There's a lot of cynicism about, essentially what hackers can do and how determined they would be. It's really hard to, when you think about, like we mentioned, the Xbox and the SAT stuff, I don't think that anybody really would have expected that, somebody would have identified, two ICs that you could solder on, some board on a PS2 to make it do, turn it into a toaster or whatever it is. But somebody figured it out eventually, So that's really like the larger point we make about all of these devices is just, just sort of work under the assumption that they're compromised, and then how do you design your network towards that, Yeah, and we already hit on that. So.
Yeah, and to the point about most of these vendors, or at least some of the larger vendors that have been around or more established, even the people within them that are doing this stuff are new to all of this, right? They're new to this InfoSec world. That's not established yet for them. So they're not, they don't have a Microsoft cert, right? That is accustomed to dealing with people that find vulnerabilities in their products and have a oiled machine to ensure that that stuff gets fixed and gets pushed out in a timely fashion.
Right, and it's very much like what we used to encounter, if you've, in the 90s and stuff like that, you'd find a bug on somebody's website and you would call them. I gave up, a long time ago even trying that, but, in the 90s or something, you'd spot something like that and you'd send an email, to the company or call somebody up and say, look, you've got, I've got command execution on your website, I'm calling you to help you, fix it. And they would just yell at you, what the hell is wrong with you? How dare you, do this? And it's a lot of that same kind of mentality. And, very much we found in dealing with vendors that we had to almost find, our moles inside the organization that did get it, that would kind of feed us good information.
And finally get the right person on the phone, and they'll get it, and then they'll fight your battle internally. Yeah,
you'd send an email about wanting to know like one minor question about sort of how they do, signing of messages or something, and somebody would send you a meeting request, and then you'd call into the call, and it would be the chief counsel for the company instead of the engineering team. That's kind of how they roll.
So some of the stuff that we've looked at, you have multiple types of devices here, right? You've got ones that really are all just one prepackaged device that you buy it that way. But several vendors have big selling points on that they're very modular, right? That the meter can fit with multiple different types of things, right? Or different types of network cards, for example. Or say, in some cases, what we're seeing is that it's all just ways to interface with some sort of a standardized interface, like serial, right? So there'll be all these different types of products that will let you hook into your existing infrastructure and then just do magical things with it over the air, right? So, well, yeah.
Yeah, and actually, if you go back far enough through like the vendors that have been in this space for a while, like they'll refer to these things as modems a lot. And if you get like the engineering guys on the phone, they'll call it a modem, and that's because really under the hood, in a lot of cases, the actual guts of what's really going on here is just just serial communication that then may or may not be getting encapsulated over some kind of other transport and sent over the air, but it really is a modem, and if you can find the right ports to connect to, maybe they're not soldered on the board, or in a lot of cases, and like I mentioned, the modular stuff, which we shall not name, has a 10-pin plug that you just literally can talk serial to this device, and we were able to use that essentially as a NIC and join that network. So that at that point we don't have to really reverse engineer anything. We're there, right? And so so basically, if you've got a meter, to Nathan's scenario of something that you took off of a abandoned building, or waited till your neighbor left town and cut the very secure little metal pin with a bolt that's like a meter or a millimeter thick off of there, then you can take this device and in a lot of cases just directly interact with it.
So with all types of modular devices, right, and known interfaces, you're going to be able to find some sort of documentation on that and figure out how to speak to it, right? With some cases, I think is it DLP3? DNP3, sorry, that they just released an open source Linux stack for that just in the last couple of months.
Yep.
And we'll probably see more of that as it goes on, right? With more of these types of devices where you're going to be driving it yourself, and development teams that are wanting to code that themselves for various reasons for flexibility.
And there's on the other side of it, and that's where like I say, we tend to be more in the open standards camp. There's a DNP3 stack that was just released under Apache license, and then there is a GPL C1219 stack as well. For us that means at the end of the day, if we can interact with that device and we can write fuzzers a lot easier, things are going to get better, not worse, from that in the long run, right?
Right, because otherwise, right, it's the well, I guess it sort of gets down to your 0-day and full disclosure types of discussions too,
right.
About sort of philosophy. But we would like to see more bugs known about and fixed, rather than more bugs that only say China or the U.S. government know about.
Yeah,
right? Somebody who's well funded in that side of things.
Right. It's more free bugs. That's right. Yeah. So, one of the points that we found with a lot of that, and in talking about like the meter tampering stuff and things like that, is that the traditional way that you would just from like a theft of service kind of perspective, and actually something that was pretty cool that we found out that we really had no idea, is that all utilities actually have like a fraud division that does this stuff now. They actually will have a list in certain target neighborhoods, I guess, of people that they know don't have service, and they'll drive around at night and look for lights on, right? And so they kind of get how to do that now. And the typical way that that's going to happen is basically you're slipping some guy $50, he's pulling your meter off, and then he's taking the load side and supply side and just jumping across to where the meter's out of the loop, or you'll actually see things like physically changing gears in a analog type meter to make it read slower, stuff like that. Well, in this case, with the new shiny stuff, you don't have to mess with all that really hot 400, I'm resistant to 110, but not at 400 amps, I don't have to worry about any of that, right? I've got 5 volts on a little board, right? And, I might just, say, for example, be able to take a cordless drill and pop through the cover on something and, add, a resistor to the wire that's actually doing the meter read, and I just drop my bill by, 50%. So, as an example.
Right.
Not that you did that.
Yeah,
No,
just
of
as an
course not.
example.
Right. Yeah, and so some of the other stuff that they're doing that the utilities aren't stupid, right? And they've been dealing with that type of physical attacks and theft of service for a long time. So they've got a lot of people that are doing things like looking at, say, trend analysis stuff, and especially going forward with some of these things where they're able to get much more advanced knowledge of what your usage looks like, and they will send people out to your house if things look funny, right?
Yeah.
So you still have sort of that meat space control of like real brains that are looking at this thing, and that will be able to come to your house and arrest you if you've been stealing service.
Yeah, and if your demand looks like this, right? There's just a big just canyon where it just drops off. That's that's pretty obvious. The thing about, and that, like a larger point too about sort of on the AMI side in general, is that instead of directly interacting with voltage coming from, from the provider, you're now subverting the data that they're gathering, that they're trusting in some way, shape, or form. Like that's really what you're more interested in at that point. And so if you can do that in a more subtle way, it's not necessarily going to get picked up. Right. But yeah, they absolutely, and one of the reasons, one of the motivations for a lot of the utilities in AMI is that it will give them a better idea of those kind of things. That they will see this really obvious drop if they have a theft of service in a traditional sense. Yeah, I think we have that.
Yep.
So.
Ooh. Oh yeah. So in general, with all of these types of things, you're going to have utilities that have to have some way to interface with their networks, right? So not only do you have all of the things that are say, controls around trying to keep out, people that they don't want to have, in there, so keep out like consumers from messing with their meters. They've obviously got to have some way to interact with that network. So we found that actually to be one of the most interesting places that we looked at. And dealing with sort of the software that the utility has and how that works and sort of how they get their magical God keys that can talk to all these things, and then really pulling that apart. Yeah. It's a sort of an equivalent of the default account type of problem that we have everywhere, where they made 1,000 devices and they put the same account on all of them, and then they hand out that password. Well, there's obvious problems with that if one gets compromised, right, then maybe they can do whatever they want with that. You could have potential issues across multiple utilities with different companies being able to access each other's stuff if it's the same product.
Yeah, well, and from the vendor's perspective, though, right? So you're selling this new technology, and you've got this customer that's you've got a lot of these vendors are startups, right? And so they've got like 5 really big customers they want to keep happy, and those 5 customers come back and say, all of our field guys, like for the old meters, they could put a voltmeter on that and see what's going on and everything, and now they have to log into a website. What? You got to do this other thing, and so. They end up rushing out these devices that do some of the interaction with a meter or other network devices without really thinking through a lot of that. And so we've seen things like signing keys on all of those.
Yeah, and we like to parallel it to some of the thoughts around say like the cellular world. So there's been talks at DEF CON in the past and Black Hat in the past about the types of software that's used to directly access, say, GSM cards or whatever, right? And that software is certainly illegal. Like you can't, you're not allowed to have that unless you are a licensed installer or whatever. But you can find it on every single torrent site out there if you know what it's called and know to look for it. So we're not in that state yet with this, but it would seem to parallel very closely with the type of environment and types of scenario. So if someone were to get a hold of certain types of devices, certain types of software, and be able to pull it apart, what's to keep that from getting released and becoming public? Mm-hmm. And then how do you protect against that once that occurs? Because all your infrastructure is already in place, right?
Yeah, and we found that's more of a, I guess I'd call that white box testing. We found that when we were given access to one of those field test devices that there were lots of undocumented commands that were under the hood. If you actually, pulled the application into a debugger or extracted the special firmware that they used, you would see all these commands that weren't known and weren't documented anywhere that that did things like enable security, disable all signing and all security for this device, and
magical functions that were hidden under there but weren't actually hooked up to, say, any sort of the GUI, so you weren't supposed to be able to get to it. But like, I'll just reattach this here.
Right. Hardwired, default passwords, a lot of that kind of stuff. So yeah, just in general, an observation that's something that we think is kind of interesting. Yeah. I guess So on the other side of it, so the reason we're all talking about AMI is because we're all getting paid to go look at AMI, right? And there's a lot of that going on. There's a lot of concern because it's visible to consumers. There's I think like 2 states now that have class action lawsuits where they're questioning the accuracy of their AMI, their smart meter deployment, their particular utility, and all these kind of things. And so, we're doing a lot of stuff with it, and we're talking a lot about it. But the real money and the real driver between all of this, and what this really comes down to when we talk about what's now called green energy and all of that stuff, is about actually getting the grid, the whole thing, not just your house.
And not just that little node at the very end that we all think about and that everyone's talking about right now, but yeah, the entire architecture that's behind it.
Yeah, and that really what that ends up being, like the end run of all of that stuff, not the end run, but the end run of all of that stuff, is getting all this data into one place and being able to then really calculate load. And so what you find out is when you talk to utilities that they essentially what they have to do now is overbuy on everything. And so I mentioned the Enron scenario. So they were a utilities commodities trader that sold short a little more than they maybe should have, right? And so some parts of California went a little dark for a while. That's because if you think about the traditional way that this stuff has been done, it's very old school. And so they had interval read data at best at like 24 hours. So you couldn't predict load like you can if you really have the visibility into all of this at something like a real-time level, right? And so the end run of that, the real driver here, is that if that's out there, then you can rapidly adapt your load and resell your surplus to other utilities and trade this stuff like NASDAQ, right? And so that's at the real core of this, that's a lot of the drivers behind this.
Yeah.
And so ultimately, somewhere with or without controls, eventually, that means that software makes a decision about where power goes and what we do with it, right? And that stuff it makes meters look really awesome, right? The meter stuff is new technology that was pushed out to an area that had no footprint yet. Didn't have existing infrastructure that you had to bolt onto or that you had to integrate with. So whenever you're taking things like, we don't think there's any Wi-Fi in distribution automation. We really hope that there's not any Wi-Fi. That's the grid part in the smart grid. Yeah, and all of these things that on the distribution and the energy management system side that are out there typically already have some kind of interface. They already have some kind of networking protocol and something that's hooking this stuff up. It may be literally like a dial-up modem that dials in at some interval or whatever it is. But they're already networked and you have to bolt the stuff in.
Yeah. Like we talked about earlier, most of this stuff, especially in demand automation, is bolt-ons to serial interfaces, right? So known stuff with known places to kind of like slice in if you were so inclined, where these things aren't really integrated, but they're modular devices that you can use to just retrofit your existing architecture, right?
Yeah.
And again, for backhaul, same types of stuff that you see in the other networks. You've got all the same tech that we talked about earlier.
Mm-hmm. Yeah, and I guess I would make the point that yes, most of those in the EVDO stuff, a lot of that's like out there now, and a lot of frequency hopping 900 megahertz stuff. Zigbee typically where you're seeing that more is actually in like plant control and stuff. So you still have the backhaul of some other tech, and then usually like short range inside there that might be Zigbee.
In some cases the networks overlap, so you could have demand automation types of things and decision type traffic occurring on the same network as, say, meter reads and things like that, which may or may not be a problem, but it does occur where they're in the same place.
Mm-hmm. Yeah, and the vendors that are big in this space are selling both pieces, and so if you think about the people always CIOs will always say the one throat to choke, so they've already got all this stuff out there, they've already invested in the AMI stuff, and the vendors that they're in deep with then come in and say, guess what, we do DA, and we've got all this other tech for that. It's a pretty easy sell, right? And so when you take those devices and you integrate them, and you have things that are existing serial that might be a nailed, like say a nailed private phone line, maybe, or some other method. The way that you're doing that a lot of times is to use a radio handoff, either an Ethernet drop or serial, and these are in boxes and up on poles.
Yeah, on street corners.
Yeah.
In some cases.
Yeah. So yeah, a lot of the same problems as the AMI side, in that you do have physical access. And
we start talking about physical access with some of these guys, and they just keep, and what they keep bringing up is like, well, it's in a secured facility, but we keep having all these problems with people breaking in and stealing all of our copper wiring. So it obviously brings to mind that they've got the same sort of physical security issues as everything else. So
right.
Even though that these are not necessarily like on your house, they're still not secure locations.
Mm-hmm. Yeah, and in the case of the Ethernet handoff, that may literally be dropping you onto a LAN that a whole lot of other DMP3 gear and everything else is on, with no other kind of authentication around it. So so essentially physical access to that port is like having physical access to a port inside a building, depending on how it's set up. Yeah, probably no. Yeah, we don't think, maybe, probably not Wi-Fi, maybe. So
we want to.
How are we doing? No, we're pretty
okay. Right, so just kind of a quick intro to Zigbee. Won't spend too much time talking about this, as Shawn mentioned. There's lots of other talks in previous years that have covered it. But basically, you can think of Zigbee as reduced complexity Wi-Fi, right? It's made by some of the same people and same IEEE people that helped define those other protocols as well. It's meant to be a mesh network over semi-low distance. Not necessarily like, I don't know, wireless USB or something, not that close, but not really long range, like 40-mile hops or something either. Have a lot of the same types of problems with key management, or key management in general, in that these devices have got to get some sort of keys that are going to drive their crypto. So there are known Zigbee issues around that with over-the-air key retrieval and things of that nature, depending on which implementation you see. Normally, in this environment, you would only see that when it's used for backhaul, like, for example, in, say, some sort of a strange DA environment where they were doing that. But in general, smart grid Zigbee is actually slightly different from the Zigbee that you may have read about or thought about in the past. It uses this stuff called the smart energy profile, which is sort of a bolt-on on top of Zigbee. So Zigbee will outline how things work at sort of the network layer, and it's kind of hard to retrofit this into like an OSI model, which is how we all think. But you can think of Zigbee as sort of transport and sort of packet layer type stuff. But then you've also got these these different types of profiles, in this case smart energy profile, which kind of interweaves with all of that. So it'll both be an application stack and talk about like individual functions and what happens in those functions, as well as like enforce special bits down in the very bottom layers about how you can do crypto, for example, as well as adding whole new levels of crypto on top of it. We used, we really like Killer Bee. We just thought we'd go ahead and plug it.
We love you, Josh.
Killer Bee is a software stack that will allow you to interface with Zigbee. You can buy little like $40 Zigbee cards that you can program with the Killer Bee software stack and interface with Zigbee networks. It does not have the smart energy profile stack, so you're limited in what you can view and what you can interact with directly with that. Currently, there's no good open source ways to do any of that. Really, the best way to do it is to just go ahead and buy expensive cards with sort of the software development kit that comes from like a Digi or a one of those types of big Zigbee players. Or
on the the other route there is obviously some of the stuff that Travis has talked about in terms of taking a device that's already on. Same thing that we mentioned on the SCADA under the hood stuff. If you can take a device that's already joined, it's taking care of the crypto stack and all the other happy stuff. And so if you can get that device at somewhere on that board, you can interact with the bus. You can just use that device essentially as your NIC, right? Right, and a lot of the early Zigbee chips that came out all had exposed buses that things like your crypto keys were flying across. So there's been a lot of attack stuff from like Goodspeed and Wright and those guys talking about how to do that at a hardware level. The newer devices, they're all coming with that integrated on one chip, so you'd have no exposed buses, and it significantly raises the difficulty level. And then you have other chips where, I know one we looked at
where literally like none of the debug stuff is turned off and those kind of things. So you can just hook directly in and be like, give me all of your memory, and it will just give it to you, including all its keys and those kind of things. And so a lot of the same problems as any early industry, where even though on paper the thing actually made a lot of sense, in implementation it was difficult. And as it has progressed, a lot of those types of problems have been fixed, but there's still more out there. And the problem with finding bugs in hardware is that what do you do, right? You go to a client, you explain that. Are they going to make the decision to replace every one of those devices? Or so it's a much more complex problem. You can't push a software patch for a lot of those types of issues.
Your 10,000 thermostats are really, really bad, and they need to go back. And you need to go roll trucks out to every house and swap them out with this newer one, right?
Jeff, probably the most interesting thing about Zigbee that we liked about it is that as a known and understood protocol, if you can find a way to get onto that network, right? So that would be using the types of tricks that we talked about, where you're actually reading keys off of a device, doing something where you can get the necessary information to join a network or impersonate a device on a network. Once you've got that, you're basically sitting at at an API for that meter and for backend stuff that's way upstream from that meter. And so you get all kinds of interesting types of things. Like we played around with ideas about, right, so SQL injection via Zigbee, right? Yeah. And being able to shove all kinds of interesting inputs back up into these API functions.
Yeah, so you have ultimately the Zigbee data that typically is being collected over a home area network is things like usage and load for different consumer devices, and I always just like simple description. This is the thing that's going to essentially tell you someday, if I guess that matters to you, via email that you left your refrigerator door open, right? So it's it's going to see these the patterns of usage across all your devices and stuff. So there's things like there's device name and all these other pieces that are being sent over that protocol upstream, and those are actually populating like web interfaces inside a utility, and those those web applications may or may not have any validation.
Right. So you have potentially have ways to trigger bugs all up that stack, right? So from simple buffer overflow type stuff on the meter itself, or the device itself, whatever it is, all the way upstream.
Okay. So somebody go home and name your meter, or name your thermostat tick or 1 = 1, and see what happens. If you get a call, then
but sort of the end run though is that we actually really like Zigbee. That all these things said about it, being an open stack that has had a lot of smart people look at, it's pretty well locked down. And you start trying to dig into how SEP works, and it's just riddled with PKI, and there's going to be implementation issues, and we'll probably find design level issues over time. But it's the best thing we've seen at that layer. I understand. I've gotten into discussions with both the vendor side and the utility side about why there are practical reasons why Zigbee's shouldn't be used for other types of transport. Largely the same types of issues we talked about earlier with being able to blanket an entire large area with high levels of packet loss. But at sort of the paper level, it's really about the best that we've seen.
Yeah, and really for us, and we feel like that's substantially a benefit to utilities, and really ultimately to everybody. In our case, in reverse engineering, like proprietary radios that had zero documentation and vendors that hung up on us when we asked questions, that was 3 and 4 months to get to the point that we got to in a few hours with Zigbee. And ultimately that point is getting to the point of finding bugs and helping the utilities and the vendors, whether they like it or not, fix those things, right? So I'd much rather have that personally, and know that you have that kind of access. And yeah, like Nathan said, I see that as being something that will be kind of iterative, where we'll run through and see improvements there. And the problem is that for proprietary radio stuff, you go through that same process for every vendor over and over again, every time. And we know for a fact, and I see some people in the back of the room, that all of us, shops that do this are going around to utilities and telling them these things, and the other shops are telling the utility the same thing. The utility's telling the vendor, and nobody's telling anybody else, right? Whereas with something like Zigbee, when flaws are found, even if they're, maybe, mushroom cloudy flaws. I don't think they would be. I'm just being facetious. The reality is that we're all going to know about it, and we're all going to see it get fixed. And and actually, we mentioned SEP v1. That's one of the other things that's coming down the pipe is SEP v2 that adds a lot more components to that whole stack.
Yeah, and I've not spent a ton of time looking at it, but just sort of as an FYI, it seems to be primarily around API stuff as far as what people really care about. There are some other under the hood types of changes, but largely it's about rolling out new feature sets to what can happen on that network. I mean, talking about like a SEP was also the application layer, as well as components of the application layer, as well as transport and all that stuff.
Now, on the other side of that, we mentioned it being the fastest path to fuzzing meter. We really like the concept of, and utilities don't necessarily because they're going to be looking at the maintenance side of that. But essentially, if you think of on the AMI side of smart meters, that really what you have is kind of one NIC that talks to neighborhood area network and another NIC that talks to the home area network. And that NIC is, in a lot of cases, a Zigbee NIC, right? When you enroll devices in the device management of all that, and we didn't actually touch on that a whole lot, but like one of the big things about Zigbee that is, OMG fail is that the key exchange pieces of that are done over the air, and those keys remain static, for a long time. So like how enrollment happens, but when people are taking things and they're burning the keys into the device because the utility controls them, and they're doing that beforehand, we can't sniff a key go over the air, right?
Right, and that, for example, that's one of the things that SEP mandates. So that even while Zigbee will allow you to do dumb things like send keys over the air, SEP will say, no, you can't do that. You have to invent some sort of outside, out-of-band pathway to make that occur.
Yeah, or extract keys, obviously, from memory, and
Right.
and we all, I think we've talked about that. But so yeah, what we like is really, in the case of a consumer to HON gateway, what you're seeing is essentially a little box that box is the one that can talk to the meter, and then the consumer can enroll their own stinking refrigerator, right? And they have control over those pieces, and that adds some separation between the utilities network and the consumer. And I kind of like it too because that also tells me that, and if you look under the hood on things like SEP, in some cases, those devices that are on your HON and that are Zigbee enabled, ultimately, if they so chose, right, your utility, and in some cases, people are being offered like a lower utility bill to agree to this, that the utility can shut off your air conditioner if they have a high load time, or that you agree to that for certain times of the day. I don't really want that, No, my house is hot. So, in the case of a consumer gateway like that, you might have more control there over what's going on. Maybe not.
Yeah. So yeah, just a complex picture of what that Zigbee thing that's not OSI looks like.
Yeah.
Right.
So yeah, essentially down at the bottom you have a low-level network protocol, and then you have these different profiles that are built on top of it, right? And so think like a 4-layer like DoD model or something like that. Oh.
Okay, so specifically to focus in on FHSS, because that's one of the things that we've seen the most often as transport for some of the interesting things we've looked at. So talking about the way these things work, you think about, when we got into this, we didn't know a whole lot about RF. So we learned a lot over like 9 months. So just as a sort of a quick primer on it, FHSS means that for any given like transmission, you're bouncing around multiple different frequencies within a band. So in this case, within ISM band, so like 902 to 928, something like that, there will be a certain number of channels within that have a pseudo-random hopping sequence, right? And so when I send a signal over, it'll send a certain number of packets, and then it'll hit or a certain amount of data, and it'll hit a threshold, and it'll packet that and throw that over one individual link. And both sides are synced up as far as what their hopping patterns are. So usually it follows some sort of an algorithm that's like programmed into the firmware, and it'll like say take something that it knows as some sort of a static value, and then can use that as sort of a driver for some sort of algorithm that tells it where it needs to be. And then so they just hop together in sequence throughout this band. And in general, I guess so. It came around in World War II as a way to get around narrowband interception, and that it can be difficult to listen in on those types of communications because you don't know exactly where the signal is going to be, right? Just do wideband interception, right? So while in World War II, or let's say even today, a lot of people that are working with this kind of stuff are doing little devices, basically. They will go out and buy like the same chip that's in use, or desolder a chip or something along those lines, and build a little board that allow them to test that and talk comms with whatever they're wanting to talk to. And so that's kind of the way that it's been done for a long time, and that was the only way that you could really interface with that stuff. Well, or short of spending like 60K on really expensive hardware to do wider band interception.
Right.
But the overall point is that if you can sniff like the whole ISM band, right, then it doesn't really matter necessarily what that hopping sequence is, right? Because I can capture them all and I can observe it as it occurs.
Yeah, we talked about that a little bit. Like, it's kind of unfortunately in double E school apparently. There's lots of good RF reasons for using it. It allows a lot of things to coexist on the same band without slamming into each other, and that's why it's used actually in a lot of other bands as well. It makes sense because of that, and that also makes it pretty resilient, pretty long range. It's not fast, not super fast, but we have, for example, looked at FHSS 900 megahertz radios that are like 40-mile ranges. So that's pretty awesome for somebody that wants to wire this infrastructure up pretty cheaply. But you do see very much today, even now, vendors that will even use the phrase FHSS encryption, which is my favorite. That's pretty awesome.
It's funny, if you actually go to the Wikipedia page for FHSS, there's like a bullet point on there that specifically says, we should have snagged that, but it specifically says FHSS is a security option, right? That in the entire EE world that we've talked to thinks about it this way. That it's like, oh, well, but you can't sniff it, right? So who cares if the crypto's not good, or if there's no crypto, or whatever, because you can't, right? How do you know where it's going to be? There's no way for you to do that, and even if you could, you wouldn't know how to put it back together, and you've got to have our secret sauce to know how this works, right? Well, that's not necessarily the case.
Yeah. And actually, that particular Wikipedia page, there's actually an edit war if you go back and look at the history of like, no, it's not, yes, it is, and then like deleting each other and everything.
Yeah,
so,
and if you're interested in FHSS, also, there have been other talks given here in the past. I don't remember if there's any this year, specifically on FHSS for individual devices, and looking at like there's a Wi-Fi 1 and some other stuff.
Yeah. And yeah, it's mostly about it's really like good from a design perspective for a lot of reasons, and yeah, the security pieces are just something that it's more convenient from a marketing perspective.
It was designed as more of a logistical issue, right? To let you get over long range without making it easy for somebody to stomp on your signal.
Yeah. And typically that's going to be frequency shift keying that's in place with the various flavors of that.
For this stuff, there's lots of different types of modulation schemes that are out there for everything that from like the wires that are plugged into your house for your broadband or your television or whatever, to this type of environment where, again, very low throughput, very long range, potentially high interference. And when you've got those types of things, what you most commonly see is FSK. So frequency shift keying is very resilient to being stepped on by all kinds of things. So we run into that more than anything else. It's not you will find other types of modulation schemes on some of these devices, but in general, frequency shift keying is the one you see the most.
Yeah, and typically hot patterns and stuff are burned in. Some of the like AMI stuff actually, because it's got more of an actual OS driving these things. You'll see some kind of algorithm they use. Actually, in some cases paired up with things like some other factor like the MAC address, and you use pieces of that or whatever to make the hopping decisions. But for a lot of these like really dumb ones that are just essentially just relaying serial SCADA, those are things where it's just like, here's the 7 hop patterns, and there's usually a default one that's just on the radio that comes from the factory. And when you read the one-page setup guide for it, it just says, did it work? Okay, So yeah, the way that we've spent a lot of time poking around.
Yeah.
No, go ahead.
So 2 major components to interface with this stuff. You need to have hardware and you need to have the software to do it. In the current world of available or fairly inexpensive ways to interface with this stuff, and by fairly inexpensive I'm meaning not 50K, right? Universal Software Radio Peripheral. It's a device. Comes in 2 versions, version 1, version 2. The version 1 is a little bit cheaper. It's older. It's been around longer, so there's more like example code for it. But version 2 has a much wider throughput. Basically, they eliminated a handful of bottlenecks that were in version 1, and version 2 will allow you, for example, to sniff the entire ISM band at once, right? Being the major draw for that one.
Yeah, and faster clock and different FPGA design, and actually can receive and transmit at the same time. A lot of other neat stuff. But the number one thing that we like about the 2 is that we can grab a much wider sample. So if we're looking at things that are FHSS, we can pull a big enough chunk that we can get the whole hop range in there, which is pretty nifty.
Right, so it can listen on the entire thing. There's fun example code in there that comes with GNU Radio, we'll talk about in a sec, that will allow you to, for example, sniff pager data across like all 80 channels or 128 channels or whatever it is. And so that's not necessarily FHSS because it's not hopping between them, but as I guess different carriers use different channels or something like that. And so with this, in one pass, basically, you can grab all of them at once with one device. So GNU Radio, right, that's the primary software that you use to drive this stuff, open source, that actually implements all of the modulation, demodulation, decoding, packetization, all that kind of stuff, all happens within software on this. It's primarily in Python with C snippets that will, well, not necessarily snippets, I guess, but C code that will drive the highly intensive stuff. So if it's got really high need for quick operations, then some of that will be put in there. It's got a very wide API that will do most of the things that you would ever want to do, right? So everything from like packetization to modulation and demodulation, encoding and decoding. And just as a quick background on what those are, right? Encoding and decoding is about how to map basically zeros and ones that like spit out of something back to data. And there's multiple ways you can do that. It may literally be that it's just 0 to 1, and that a 1 is a 1 and a 0 is a 0, but it may not. There's other ways to do that as well. And then modulation is specifically how that signal is sent across the air. Like when you collect something inside the usurp, modulation is how information is represented within that stream. So frequency shift keying, like we talked about, basically means, so 2FSK, the one we most commonly see because of the long range purposes and that. FSK basically means that there is sort of like a center channel like this, right, that you would focus on. That'd be the center of the channel. And then you'll have 2 that are off to each side that basically it bounces between. And like when you're on, like that.
Like that right there.
Right. So if you were to average everything to the left side of that and everything on the right side of that, they'll basically collapse into 2 points that are to the left and right of center. And as it's on one or the other, that represents information.
Right. And now I have to jump like way back now.
No, sorry.
That's okay. But and like the larger point, like the way I explain it to people is that we all sort of understand that like Ethernet is pulses on a wire. And those pulses then map out to to zeros and ones ultimately, like the difference in voltage on different wires on an Ethernet cable. So you're really doing the same thing with the radio. It's just there's lots of ways to do it, and there's a lot more math involved, and it's a little more complicated, and it's obviously lower lower throughput. But it really is the same principle. You're just trying to get down to to bits at the end of the day. I'm gonna see how far back I can go. Don't look. Just close your eyes. Don't look. You didn't see that. Oh.
Is there anything left there?
Yeah, okay, cool.
Yeah. And so just the overall point about GNU Radio has way more stuff than we ever touched with this and would need. And there's all kinds of interesting things hooked into it, from like doing radio analysis of like stars to tapping into like NOAA weather stuff, and it's all kinds of interesting stuff in there.
Built-in vocoder as well. So if you, I don't know about the auto tune or not, but if you're running a DJ operation or something. So so essentially, like if we don't know, if we have kind of a rough idea what's going on with something, just the real simple way is that we just sample data, and we look for peaks, we get as close to the the target radio as we can.
We get real close to the signal is the strongest thing you're going to see, and then just watch for patterns.
Yeah, and actually, we've in cases where we've had controller radios, where we can we have control of the traffic stream, we can literally just send one character, wait a second, another character, wait a second, and we can see, visually that those peaks pop out, and that's the hop sequence, right? And once you see that go through and repeat, then you know what it is.
Depending on what type of algorithm they used, it's not uncommon to see one that just loops forever, right? So if you watch it long enough and get that pattern down, then who cares what the algorithm is? You now know what the pattern is that you need to have to speak with a given device or listen to a given device. So.
Yeah, and then what we found, in terms of just cheating basically, is that there's lots of places where this information will leak. We were dealing with in a couple of cases vendors that wouldn't tell us anything about that. We would guess, we would get the engineering guy and just throw random, is it, what do you think, BPSK? What do you say? Just don't say anything if I'm right, and he would sort of cough or something. And so when you have that kind of scenario, what we found is that we found some really neat things from patent data. FCC ID lookups are really good. There was one case where we looked at a vendor where there's actually there's a place in your FCC application for your radio where you can say, please don't disclose this information because it's proprietary trade secret, and then they just did it anyway. So it's like the letter that says, please don't tell anybody our hopping algorithm, and then the next exhibit in the FCC data is the hopping algorithm. And yeah, so all of the EMI test report data and everything else out of the FCC tells us a lot about what the radios do. And actually we'll get to this on a victim radio here in a second. We also found that looking at and actually, for what it's worth, firmware extraction in this case for us a lot of times didn't help, because this is typically stuff being done on board, so that the firmware will have something like a draw unicorns function that just talks to the radio, and then all that stuff's happening in a lot of cases in hardware. The firmware might tell us about the larger protocol that's it's communicated on and stuff, but to get to the radios, we're usually looking at ICs and RF modules on the board itself. So yeah, and then actually you can go pull the vendor bios and resumes and things like that.
Start looking at job postings and things like that, saying it would be great if you had specific expertise in blah. Oh, now I know what you're. Yeah, that's it.
Yeah, we're looking for somebody with GFSK experience, whatever it might be. So, so this is actually a digiboard that is basically a SCADA RF relay or serial RF relay. You could use it for lots of other stuff too, but these get used for utility kind of stuff. So what most of these will have when you get down onto the board is there's RF shielding that the FCC requires, and that's usually what they're put there, a little pretty sticker. And on there, there's obviously the FCC ID. Usually you'll see that on the outside. We just looked at when we walked up here, we looked at our microphones and wrote the number down on those. So we're, if you lose signal later today, we're terribly sorry. But yeah, you usually pull the FCC ID, and then once we pop, or once we pull that off, from the FCC test information, in this case, for example, it tells us the radio's range. It tells us actually the dwell time per channel, and channel width and things like that. And also, in their case, the modulation type, which may or may not actually be accurate, in some cases. But yeah, once we pop shielding off one of these devices, don't look at, I'm sorry I didn't desolder it. I was upstairs and I only had a screwdriver. If you pull that IC and, a lot of cases, maybe you need a magnifying glass or something like that, you pull those IC numbers, you'll get a data sheet. And in a lot of cases, the RFIC will literally tell you, for example, how to drive it, over the bus, if you want to do that, but also the modulation types supported, the clock rates and the bit rates. And when we demodulate this data and try to turn it into zeros and ones, that's what we need. We need all of those values to match up to what the radio originally sent. Yeah.
Right, so this is just a snapshot of what we were talking about, of mapping the entire ISM band, right? So every single one of those peaks you see in the top, every one of those is a channel burst. So that's a burst somewhere within that hop. We are, in this example, specifically focusing on one channel. That's the one that's got the blue that's coming up right there. And then on the bottom side is that being decoded. So focusing on that individual channel just for this graphic, what pops out at the bottom, right, is roughly zeros and ones. There'll be some sort of encoding or decoding that may need to happen, so it may not be exactly a 0 or a 1, but you're now very close, and then oftentimes it's identical.
Yeah, well, and that's, yeah, in clock recovery and soft bit stuff, what's happening, because radio is not, on the other side of it, I just told you it was like Ethernet, so it's not like Ethernet, right? So, the voltage on a wire can go, very predictably to really clear levels, right? But in the case of radio, with signal and bleed and interference and all that, it's going to be more like a curve. So usually what's happening is you're looking at the symbol rate, and then you're converting that to, that's going to map to some number that's closer to 0, closer to 1, ultimately. So yeah, I don't know, can anybody know what that is? Is it like B's or C's, or it says, yeah. But yeah, that's kind of it on the other side of it. That's what as Nathan said, what the channel we're watching, what that maps out to.
So yeah, talked about this a little bit earlier. This is just a zoom in on one individual burst and what that looks like. What this is actually drawing is an averaging of lots of samples over a short period of time that are then showing you exactly where, where that signal is. And so it's always in a constant flux between basically these two different, or it's averaging to two different frequencies that it then shifts between to represent that data that we just saw in the previous one.
Yeah. Like 0 minutes.
Yeah.
Yeah. And so, yeah, ultimately on the other side of it, like we say, when we can do wideband interception, the FHSS piece, depending on how many radios are in use, and there's obviously some challenges if there's a lot of traffic, but if we have a single sample, at the end of the day, that's sequential, right? That took place over time, and when we break that out, right, it ends up being, say IP traffic. It's got headers in session information, all that stuff there. We don't really care if we followed the hops around. It's not necessarily relevant to us. But yeah, you still need to identify the modulation scheme, encoding, symbol rate, big endian, little endian, lots of other stuff. It's really hard. Yeah, and so yeah, so pretty much once you've started with your sample, and ideally it's a situation where you can generate traffic, what you basically then are doing is spending a bunch of time taking those samples and throwing different demodulation types and different kinds of math at it based on the things that you could guess from the ICs, and you could try to extract from whatever other sources you could find to get it as close as you can. And when actual data comes out, then you know that you got it right. So
wrap up.
Yeah, and that's and yeah, I will make kind of this point too, that in a lot of cases you might, and actually with some of our stuff with Zigbee, like we mentioned, that there isn't necessarily a really easy SEP stack yet for us. We still could do a lot of testing with Zigbee, because if we could just generate traffic, just general purpose traffic, we didn't necessarily have to know at a packet construction level what exactly was going on. So even if we have bits, if we know what those bits are doing, it still gives us something, right? Yeah, and obviously, especially if there's no other any other kind of timing or other sequence pieces in place, and we can just directly replay that data, then we may not even care. We don't really necessarily need to even break it apart. Yeah, and yeah, in some cases that may mean that you could follow hop sequences and hit it at the right value and brute force FHSS. Oh crap, we're out of time. Sorry. Yeah, and so yeah, related to just general other stuff with a lot of these proprietary radios is they have something like a BSS ID in authentication and things like that. A lot of times that's just a number that's in firmware and doesn't do any other validation.
Right.
So there may be something like a ProMISC mode, somewhere in firmware that you can flip on. So if you have control of the radio itself, it may just sniff for you, right? Yeah, may just allow, default settings might allow anybody to join. So.
Yeah, so just a summary of everything we've talked about so far. We like standards. We like real crypto that's been actually looked at by people in the industry and by people smarter than all of us. Pay attention to AMISec. Go out and look at some of their stuff. I know there's people here that are members of AMISec. We'd like to plug it. It's good work where they're going.
Yeah.
Utilities, yeah. Utilities really need to push. They're the ones that have the money in this particular thing. So they're the ones that ultimately can get things fixed, right?
Yeah, well, and actually on the other side of that too, and presumably not everybody in this room is from the utility sector. I mean, we as consumers too, you need to ask questions. I know we were on site for a particular utility, and they had an email that made the rounds that went to like their contact us web form, and the person who sent the email just happened to be a cryptographer and asked a bunch of questions about what are they doing.
It went all the way up to the CEO and all around. So
yeah.
I know that people are paying attention.
Yeah.
So
yeah, ask those questions as a consumer. Yeah, and yeah, none of this is necessarily new stuff. It's just sort of a different way for it to happen. Yeah, and we kind of think it's being basically nation state attackers and also kind of the backyard electricians. Like those are your two sets of attackers, different sets of problems. Good night, everybody. Enjoy the ponies. I think that's here. Ponies.